So in this section of the course, we're going to be talking about Azure Web Apps and Azure App Services. Now, app services are sort of an in-between service between having complete control of your environment, which you do with virtual machines. So with a virtual machine, you can upload your executables into an Azure virtual machine, install it however you like, and have complete control of your environment. As opposed to the serverless technologies like Logic apps and Function apps, where you upload your code, but Microsoft Azure is entirely responsible for how it runs it. Now you can set up in the settings section how you want it to run it, but you have no control over the underlying server. The in-between of that is called Azure App Services. This is Microsoft's platform as a service model. Now an app service is a way that you can create code, package it up into a zip file or some package service, and upload that into Azure. Let's create our first app service. If I can go into the Add Resources section and find web apps, or I can do it right off the menu in terms of app services. I'm going to create a web app. Now, it used to be a few years ago that there was a difference between web apps and API apps and mobile apps. But in these times with the Azure Resource Manager model, all app services are web apps. And whether it's an API app or a mobile app, they all have access to the same underlying functionality. So when we create a web app, first thing we need to do is we need to give it a name. Now notice that it has the .azurewebsites.net extension, which means this is a fully qualified name that has to be unique across all of Azure. So I tend to give these names with my initials, so AZSJD and then new web app. My subscription is the pay-as-you-go. Now you might be running off the free plan, or you have an MSDN subscription, or your company has an enterprise plan or other model. Mine is a pay-as-you-go subscription. As usual, I'm going to create a brand new resource group for my app just so that it makes it easy to track it, track the costs, and also to delete it and set permissions and other things like that. Now right away we're given the choice between a Windows app and a Linux app. Now the choices here are that on a Windows app, obviously we have the choice to include application insights. On a Linux app, our choice then becomes running in PHP. For both, we can choose to upload the code in a package format or to run it as a Docker image, which is basically a container running inside Windows or Linux. Okay, so I'm going to create this as a Windows app that's running code. That means that I have to upload code in order for this to operate. Now the most important decision that we're making here, besides operating system and then the type of image, is the app service plan. An app service plan is like a hosting plan. Now, believe it or not, Microsoft does have a free plan. They also have a number of paid plans, and we're going to review that very briefly. So I'm going to call this new plan. I have to give it a number so make it unique. I get to choose which location this runs in. So within an app service plan, you get all of Microsoft's 55 plus regions. Now, as usual, you don't get access to all 55 because some of them are government and Department of Defense and other restrictions like China. So I'm going to run this in Canada. Let's look at the pricing. So we've got basically three major options here at the top between dev test, production, and isolated. The dev test option has a free model, F1. Now you do not get very many options with this. Okay, in fact, there's nothing listed in terms of the benefits. If we go up to the D plan, that does cost us here at $14 Canadian per month. And we are running on shared infrastructure. So our apps are running alongside other apps. We're only given a gigabyte of memory, and it's calculated in terms of the minutes per day. So we get 240 minutes per day, which is 4 hours a day of CPU time. Okay. Now on the shared plan, we can set the domain name different than what we created it. So you remember I created the AZSJD new web app domain.azurewebsites.net, and under the free plan, that's your only option. But as soon as you get to the shared model D plan, you can basically set up your own domain name and redirect it. Moving up to the B series, that's basic pricing tier. You can not only have a custom domain, but it supports HTTPS. You also can scale. So the concept of scaling, we're going to talk about in a video very shortly, but this is manual scaling. So you are making the conscious decision to log in and to upgrade to a second or third instance for your application if you have performance issues. Now, this is the first plan in which we can see you get this Azure Compute Units. So the B1 plan is listed as 100 total Azure Compute Units. When Microsoft lists these numbers, it's basically a number that's used to compare plans relatively to each other. So if B1 is set to 100, B2 is set to 200, you can expect the B2 plan to be twice as fast as the B1 plan. They're not going to tell you exactly the CPU speed or the number of CPU cycles, etc. But on a relative basis, B2 runs executions twice as fast as B1. B2 gives you double the memory as well and double the price. So B1 is running at $79 a month, B2 gets you to $150 a month, and B3 doubles that to $314. Again, double the memory, double the performance. You'll also notice they're listing it as an A-series equivalent. So it may or may not be running on an A-series instance behind the scenes, but this is effectively an A-series for the purposes of setting up our web app. Now, Microsoft does not suggest that these are good for production workloads. Again, we don't have any sort of auto-scaling. There's no backups here. When we get into the production, we'll see the benefits of running production workloads. Now, the S1 series has an equivalent ACU to the B1 series. You get the same amount of memory. It is also running on an A series, but the price jumps to $104 a month. But when we look at the features, we can see that it includes auto-scaling, it includes staging slots, which we'll talk about later as well, backups, a load balancing technology that crosses regions. So that would be sort of the first series that Microsoft recommends for a production workload. What they really want you to do is to get into the premium series. Now we're starting to get into the $200 a month ranges. Now you'll notice it goes from being an A series equivalent to a D version 2 series equivalent. The features are pretty much the same as the S1 plan, but now we're basically doubling the memory and doubling the performance. Okay, the number of backups per day, the number of staging slots goes up, the number of backups per day goes up as well. So, and the amount of instances it can support. Do keep in mind that for every time you scale an instance, you are basically adding to the cost. So although this could be $200 a month on the S2 plan, if you have 2 instances of that, that would be $400 a month. So there's a pricing caveat that they don't really call out here. But basically, web apps have these types of plans, and the difference between standard and premium has to do with the amount of instances and staging slots and backups. Okay. Finally, we get into the isolated model, and we can see that basically Microsoft is really ratcheting up the price here. So now we're getting up to $280 a month minimum. But there's an asterisk here, actually, if we don't see it on this page, but the isolated model has a minimum cost that is separate from the instance cost. So you're actually paying $1,000 a month plus $300 a month for this, okay? But hopefully you would use more than one instance, and then that $1,000 would not need to be paid again. So isolated, the pricing on this screen is a little bit misleading. I would not choose it unless you really needed isolated hardware that is basically says single tenant system, so you know that your apps are the only apps running on that hardware. It's running on its own network, including your own setup of a virtual network. Okay, all the private accesses, etc. So for real production instances that really need to be running on their own, that isolated network exists. I'm going to create this app on a, let's call this D1 series shared infrastructure. It's not a reasonably priced model, and it's good enough for our purposes. We'll show you how to scale up to get to the models where you can actually do manual scaling. I'm going to pause the video, and in the next video we're going to complete the creation of a web app. So we've chosen the D1 series running in Canada East. I'm going to click OK. And so what we have here is a web app running on Windows where we're going to be expected to upload code, and it'll be running in Canada East on a shared plan, which is $14 a month. I'm going to click Create. This is going to take a minute or two to create, so we'll pause the video and come back. So that was very quick. Let's look into the resource group. Remember, resource groups is how Azure organizes its resources. We have the app service itself and the app service plan that we created, remember. If we look at the deployments that we created, it can actually tell us, I have to scroll here a little bit, it actually told us that it took only 40 seconds to create. So it's pretty amazing to get a web app ready to go in 40 seconds. Now we're in the web app. Now we can see here that there is a URL that we created. Well, Microsoft does have a web page ready to respond just to say your app service is up and running. So we can tell that our app service is actually responding on the URL that we created. Now, we also see that the app is actually running in an app service plan, which is listed as shared, small, which is the D1 plan. Now, if we wanted to start to take advantage of things like scaling, we can go into the app service plan and say scale up. And by scaling up, we can choose a higher or lower app service plan. For instance, the B1 plan allows us to have manually scale up to 3 instances. And even though this is still running as a tenant, it's not the same as the shared infrastructure, which is limits the amount of CPU time per day. We are a full tenant within whatever hardware this is running on. Okay, so it's very easy to switch, or even if we wanted to switch to production workload, you could go to that tab and choose to switch to that. So we're going to let that run. It should take only a few seconds. So just like that, we're upgraded to the B1 small app service for our web app. Now, this app service plan actually can host more than one web app. So another key element of web apps is that you can have multiple web apps hosting completely different websites and APIs running on the same app service plan. Switching over to the Azure Docs website, we can see that for app service plans, we have a 10 app limit on the free plan, a 100 app limit on the shared plan, and as soon as you get up to the basic plan, you can have an unlimited number of web apps running on the same app service plan. Now, do keep in mind that you are limited in terms of disk space, so you can only upload as much as you can in terms of that disk space, and you're also limited in terms of memory and the CPU being allocated to that. So as long as your apps are not taking over and not requiring a lot of intense CPU usage, you can have a lot of apps running under the same plan, and even on the free plan. Now, as far as being able to upload code into web apps, you have a lot of options. Right off this homepage here, we can see that there's an FTP server, an FTPS server, and also a way to log in to that in order to upload code. So if you have a deployment system that can support FTP, then that is obviously one way to do that. Another way to do that, let's go into the quick start here. Another way to do that is to, actually we'll switch over to the deployment center, is to use Azure's new repos, which is part of Azure DevOps services. Azure is Microsoft purchased GitHub, and so there's GitHub integration. So in a case like this, when you push code into your GitHub repository, even a private repository, then that triggers a push into the Azure web app. So basically it's a continuous deployment situation when you hook up this into GitHub. With repos, you do have some ways of doing some automations and code things like that. You see it supports other things such as Bitbucket, Git, file systems like OneDrive and Dropbox. FTP we talked about, that there's an FTP setting. And there's also public Git and Mercurial, which uses a different system than the GitHub integration. Okay, so tons of options in terms of getting your code into an Azure web app. Now, in conjunction with that, having deployment slots would be useful for something like this. So you could have a staging slot. Right now, the basic plan that I'm on does not support deployment slots. But if I was on the standard plan, I could have the production slot, which only I can deploy to, and then the staging or testing slot, which is gets continuous deployment with one of these sources. And so you can test your web app from a testing location that is different than your production, all automatically handled by Azure. There's a process called swapping, where you can, when you're ready to go live, your production becomes your testing becomes production, etc. So Azure web apps are basically designed for this kind of continuous integration, continuous deployment system, which is pretty cool when you set up your applications to automatically push as soon as code is committed to repository. Now, one of the requirements of the exam is to create and deploy into containers. So if we go back into web apps, which is a popular featured app, I'm going to create a new web app. And we're going to put it into an existing resource group. I'll put it into the new web app one. And instead of using a Windows code deployment, I'm going to do a Linux Docker deployment. Now I can't obviously put a Linux Docker image into my existing Windows app service plan. And so we are sort of forced to create a new app service plan. So let's go create new, give it another name, AZSJD, new container. And let's look at the pricing tiers. Now for the Linux containers, we've got our premium and standard pricing in production, and we only have our basic in dev. We do not have a free plan for the Linux pricing. So let's put it into a B1 plan for now. Okay, and say apply. Now, obviously, what we want to do is deploy a Docker image into it. So what do we want to deploy into there? Now we can choose one of Microsoft's templates under the Quick Start. We can deploy from the Azure Container Registry, ACR, or from Docker Hub, or another private registry. Okay, that's a single container model. Let's choose the sample. So there is a, let's choose the static site. Okay, it's a static web page served from an Nginx web server. You can actually see the image that it's going to be pulling this from. Okay, so if I said apply, when I create this web app, it should be the static website quick start sample. But again, you can choose your own Docker Hub, push, etc. to get this web app. Now, this is the quickest and easiest way to create a container within Azure. Right? See how I only had to fill out 3 or 4 different things, and I say create, and I'm going to have a containerized web app running in seconds. Now, it's not the most flexible one, so when we get into talking about Azure Kubernetes service is full-on, containerized services. This is actually just, the simplest and easiest way to create a container within Azure, an Azure container instance, essentially. Okay, so I'm going to click Create, and I'll pause the video for that. So creating this deployment took us just a minute exactly to get a container app going. Okay, let's go into the container app. And we have a very similar layout to the Windows container. We have a URL. We can see our app service plan is the B1. I called it container. We have an FTP method of deployment. Let's click on this URL, see our static site. We're just waiting for Nginx, obviously, to start and to service this site. And so that's an extremely simple static website that just says hello. This is being served from a Docker container running Nginx. So very simple image, obviously, but this is being served from a container running within a Linux Azure App Service. When we go down into the deployment center, back in the portal, we see a completely different setup, right? Whereas on the Windows code option, we had GitHub and a lot of other options. Basically, this is giving us the Azure DevOps deployment option, so we can get our deployment pipeline into the web app. Okay, so we can then go through the configuration to set up the deployment, but completely different than obviously what we saw in the Azure web app for Windows. And if you ever need to readdress the settings of the container, remember when we set it up, we made some choices in terms of container settings. If you go down into the settings option for container settings, we'll see we did the quick start method, but basically quick start is basically just setting it up as a Docker Hub image from a public repository. Continuous deployment is turned off, and we can see the log files from that container. So we always have access to change this from one image to another or to our private registry, etc. So in this video, we're going to talk about web jobs. Now we're back looking at our Azure web app that was a Windows app that had code deployments to it. And we know what a web app is at this point, right? It is a website that we've coded, uploaded into Azure. It has an addressable URL that is publicly available, and we're basically able to deploy code and call code on demand. But the thing with web apps is that they're not continuously running. Somebody does have to go to this URL to get the code to run. What do you do when you have something that needs to run on occasion or it needs to run continuously relating to your website? Let's say you have what is called a web job. So in traditional coding, you would have created an app and would have installed it as a Windows service within your web server, or set it up as a cron job or some other way for having code to occasionally run. So let's go into our web app here, and we're going to go down to the setting underneath settings that says web jobs. So web jobs, as it says, provides an easy way to run scripts as background processes, and it runs in the same context as your web app. So you do have a way of uploading code into Azure, and you can set that to run however you wish, right? So let's give this web job a name, AZSJD web job. We do have to choose some type of file to upload it that contains the code. Could be a PowerShell script, could be an executable. And we choose whether the code just runs continuously or something happens to trigger, and it likely is a schedule. that's going to basically a cron job will trigger this on a every 5 minutes, every hour, every day basis. You set up your schedule using cron expression, or like a Windows web service, a Windows service, you can set it up just to continually run and to expect that it runs continuously. Now, one question that does come up is when you do scale this web job, a web app, let's say you have 2 or 3 or more instances of this web app, do you want 2 or 3 or more instances of those web jobs? So for things that are, cleaning up directories, doing stuff, it's a batch process, maybe you only want 1 instance of it running. These things are not designed to handle multiple instances of that code. So perhaps a single instance running in a continuous fashion is the method that you want. So we can see here, according to the docs, that the following file types are supported. So we've got scripts like CMD files and BAT files, compiled executables, PowerShell, Bash, PHP, Python, Node.js, and Java as jar files. So essentially, if you can get code into one of these executable formats, you can upload that using a web job, and again, set it up to either run continuously or to run on a schedule. So one note that I should point out here is that web app can time out after 20 minutes of inactivity. So that's one of the reasons why having this type of code running in a web app is not always great, because obviously if no one's visiting your website, then that code will never run. So in this video, we're going to create a web app and deploy some code from GitHub. Now, we'll say there's a script on the Microsoft Docs site, and I'm going to basically use this as a basis for my own script. If I go into my text editor here, we can see that I've basically copied the script and I've modified it. Now, I've chosen a GitHub repository to deploy, and it's a HTML, CSS, JavaScript site, so there's nothing complicated about it. It's a pure bootstrapped site, and we're going to deploy that to the Azure App Service. Okay, so pretty straightforward. Now, we're going to establish here. I've got my PowerShell 6. I'm using the AZ module. I've connected to Azure, so my PowerShell is connected to my Azure account. So let's set up a couple of variables. The first one we can set up is a link to the GitHub repo. And so this is a web HTML repo. You can choose your own repo. You can use any of the other Azure samples. This is pretty straightforward. So that's the repo we're going to use. And we'll take advantage of a randomization function that will get us a web app. So my web app with some type of a random element. That way our web app will guarantee to be unique across the universe of web apps, pretty much, right? And I've decided to deploy these to Eastern US. So I'm going to set up the East US variable. Now, these are all setting of variables. We're not actually done anything yet. As we normally do, let's start by creating a resource group. Okay, so the new -az resource group, giving it a name and telling it which location, which will be our East US location. So I'm going to hit enter to that, and that's pretty quick. See, it's created us a resource group in East US just like we asked. Now there's two components to creating an app service. One, of course, is the app service plan. Either you're using an app service plan or an app service environment. This is the app service plan, and we've chosen the free tier. You can say that the -tier equals free, and we're putting that in our resource group in our location with the name that we've assigned it. So this will take a moment to create us a new app service plan in the free tier. And really this was less than 10 seconds. So we've got ourselves a Status is ready, so we got ourselves an app service plan and the provisioning succeeded. Now, that's not the web app. That's just the hosting element of it. So next we want to create the web app itself. So I'm going to say new -az web app. We'll use the same name as that we've defined, location. We're going to use the app service plan, which happens to have the same name as our web app, and it's going to be in our resource group. So this is going to establish us an empty spot in which we can deploy our code. I love these progress bars. Allows us to see how far along it is. So now it has created us a web app. A lot more information there, but we can see that it's my web app 18029452003.azurewebsites.net. Okay, so that's all pretty good. Now, right now that web app is pretty empty. Actually, if we go to grab the URL, if we open up a new web browser, I'm going to try to drag it in here. We can see that the web app is just returning us your app services up and running. Okay, so it's completely empty. This is the default look of an app with no code in it. Now, what we said we wanted to do was we wanted to deploy this this sample site from GitHub. Now, we did set up the GitHub Git repo variable here up at top. So what we're going to want to do is we're going to want to set a property here. So I'm going to just there's another variable called properties object, which is a JSON array, an object, which contains our Git repo, which contains our the master branch of that repo, and I'm just going to set that property. And now's the sort of the bit that does the work, that does the deployment, right? So the set-Azure resource is going to assign this property to this resource, web apps name /web. Okay, so if I do this, we're expecting the deployment to be set up. So we'll give that a second to do that. All right, so the set-az resource command has now associated this GitHub repository with our web app. And if we now go to that web browser, to the URL that we created, we can now see this is it's pretty straightforward HTML, JavaScript, CSS site. It doesn't have obviously much to it, but it's just an HTML site. So our deployment using GitHub has worked. Now, this is a one-time deployment. This is not the same as continuous integration. So if I was to update this GitHub repository, we would not expect the website to be updated. Continuous integration, there is a completely different script for it. If I pull it into frame here, it actually involves getting a token from GitHub in order to do an integration. And then, even though we're still using the properties object, we're passing the token to authenticate, and then the GitHub can basically push whenever there's a compilation or a check-in. It can actually do a push to Azure to get that to redeploy.